In the last video, we talked about how to write letters with LaTeX. Here, we want to see how we can write books with LaTeX. If you remember when we started out, we talked about different document classes where we had things like article. We saw possible document classes like articles, reports, books, Beamer, and then there's the possibility of having customized document classes. So in this case, we'll be exploring basically the book document class and some other things we might consider in that regard. So here we'll be looking at, we have the following goals: to set up a professional book project, structure chapters, sections, figures and tables, maths and theorems. And we add references, index and glossary, and build reliably with Latexmk plus Bible. We talked about Bible under bibliography and referencing. Okay, so the recommended folder structure for if you want to write a book in LaTeX, this is how it goes. Of course, a book is not a straightforward project like just writing an article. So it has multiple parts, and this is the overall structure that is recommended. So you have the book project, right? Of course, it has its title and everything. So you have the main.tex. That's where you are assembling all the chapters and other things that you would have put in place. And then there's a preface.tex. In the preface.tex, as the preface implies, right? That talks about, where you have the some preambles and all of that. Then you have your chapter. So whatever number of chapters you want to have, maybe you have chapter 1, ch01.tex, ch02.tex. So these are different text files containing the things you want in the various chapters. So you can have as many chapters as possible, like I said. Now the figures are in a folder. So in that folder, you can have different figures. They can be PDF figures, PNG figures, or JPEG figures. And then for references, you need a .bib file where you have your references. And of course, you have build. This is for compiled output. It is optional, by the way. Then you have index to the index slash glossary auxiliary, and you have LaTeX mkrc for build. So it is for build settings, and then you have the make file, which is also optional. So you're going to see all of these at the end of this whole thing. We're going to demonstrate with a proper folder containing all these things. So let's move on. So if you want to talk about the preambles for a book, this is what you can see. It's pretty lengthy. It's talking about just preambles alone. So see what goes. Minimal solid preamble for the book class. So you have for the main.tex file now, this is what you're going to have there. Documents class, 12.1 side book. You can use 2 sides for print ready. So if you want to have a book where you can have print on both pages, so you use 2 side. Then you have for language and encoding. So you can use package UTF-8 for input and encoding. So this works for PDF LaTeX only. I mean, I've been using PDF LaTeX for the most part. Then you can skip if you're using X LaTeX or Lua LaTeX. I'm still not sure about this, but I've always used PDF LaTeX all along. Then you can also use package T1 for font encoding. Then use package English for Babel. So now talking about typography and layout. So we've seen some things like this before. So you use package microtype geometry where you set the margins of the paper A4, and you have 1 inch up and down, left and right. Okay. Then use package set space and here you can use 1/2 spacing if desired. Then use package graphics, of course, that's for figures. Use package book tabs for niche tables. Use package caption. Use package sub caption, right? Especially if you have a table with maybe if you have sub figures under a particular figure, then you can have the maths and theorem environments. You've seen all of this before, so you can use package math tools, AMS math, AMS symbols, right? AMS THM, that's theorem. Then you can then define environment for theorems, new theorem chapter. I've talked about this in the past. So you have for theorems, for definitions and all that, and they take the form of chapter. So the numbering will be according to chapter. So in chapter 1, the first theorem will be maybe something like theorem 1.1 or so. Then you have cross references. So the idea of cross references, like we've seen previously, is that you can maybe you have a citation or you have a link. So you can click on it and it will take you to the citation or open the link that you may want to that the link is referring to. So open it. If you have a citation, right? If you click on it, it takes you to the reference for that citation. Then you can use package name in link, clevref for hyper after hyperref now. Then for bibliography, you can use BibLaTeX plus Bible. So use package backend Bible style author here, sorting NYT BibLaTeX. Then add bib resource. So you have bib and references.bib like that. And then you have index and glossary. So use package I make index. Then use package acronym glossaries. So if you want indices, the idea of indices, you're going to see that, right? Like maybe where some keywords appear, you want to maybe you're looking for a particular word. Maybe you have a very big textbook. You can go to index to see where the pages where these words can be found. So maybe you want to read, you just found a new word like maybe quantum, and then you don't know where quantum can be found in the textbook. So you just go to the index and then you see the pages where the word quantum is used. So you can go straight to those pages. Now for acronyms, talking about glossaries now. So you can make glossaries. So maybe you have acronyms with their full. So this one helps you to get the acronyms on their full meanings. Then you have custom commands. So maybe you want anytime there's mathbbr. So anytime you use \r, instead of typing mathbbr in full, so once you use \r, it will automatically give you mathbbr. And then you can talk about \tem for text, number one, index number one, and things like that. Then you also have the front matter. So we're dealing with a book now. So you got to talk about front matter. Front matter includes things like the title of the book, the author name, and the date. Okay. Then you can then begin document. So after begin document, they have so you activate the front matter and then you have make title. Then you can have table of contents and then you can include the preface. Okay. So you see this include keyword. You're going to talk more about it later. So you include the preface, which is like the part containing the preambles. Then you have the main matter where you have the chapters, include chapter 1, chapter 2, chapter 3. So you have a folder called chapters where you have each of the text files for each chapter. Then you have the back matter now. So here you have, so for back matter, you can have something like print glossary. So you can type acronym type, title equals list of acronyms. Then for print glossary, you have title equals glossary. Then print index, print bibliography. So here you're calling forth all the glossaries, all the indices, all the things in the index and the bibliography itself. Now let's look at a sample chapter file. So all we've seen now is the main.tex file, right? So if you talk about a sample chapter file, see what it looks like. Okay, so let's say this is chapter 1.tex now. So you have chapter ch01.tex inside the chapters folder. So for instance, you have chapter, the first chapter is foundations, right? Label chapter foundation. So this label is important in case you want to refer to chapter 1 in any other place. So you can now do \. Okay, I think you're going to see that here. So this chapter introduces the term continuity. So this term continuity and term compactness. So this term you have used here, it means they are going to you're going to see them in the indices, in the index. That's why you use this term for them. Then you have section. So under chapter, you have section, right? So you have section sets and functions. Let F be \r. So because we defined this \r to be mathbbr, so a point x0 in R is a term, or it's a fixed point rather. So it means you're going to see fixed points in the indices. If f of x underscore 0 is equal to x underscore 0. That's f of x0 equals x0. That's the idea of fixed point, by the way. Then you can then talk about, in case you want to define something, so you can now say begin definition, and you want to define continuous. So you now say function f is continuous at x0 if for every epsilon greater than 0, there exists delta greater than 0. Such that the absolute value of x minus x0 is less than delta, implies absolute value of f of x minus f of x0 less than epsilon. So that's definition. So we begin definition, end definition, like that. And then we'll talk about theorem. So you have a theorem you want to talk about. So you have the Banach fixed point, and you can label the theorem like that. So on a complete metric space, the contraction has a unique fixed point, okay? And then you end the theorem. Then we will refer to THM Banach. So this is you referring to this theorem here. So it is going to come out in form of a number. You're going to see that when we do the mini project. in chapter, so you can also refer to the chapter called applications, right? So then you have section for figures and tables. So you can also see CREF architecture. So this figure now is the table for architecture. So you bring in the figure, and the caption is high level architecture, and you have this HT talking about hair, top, and all of that, where the figure should be placed. Then you have another table right here. This is about you have begin table, HT centering, example data. So these are a table. So you have left, right, right. So first column is left, second column is right, and third column is also right. So you have item alpha, value 10, value B 25, value A and value B. So for alpha, it's value A is 10, value B is 25. For beta, value A is 12, value B is 30. So like you're just showing some example data. And then because this table, and then you have a citation here now. So we cite text at Lampo 1994 LaTeX for LaTeX fundamentals. Now let's talk about preface and front matter. So the preface is where you have the preamble kind of, or no, not the preamble per se. Preamble is all this use package this, use package that. We already saw that in the main text. Sorry for that confusion. The preface and front matter simply talks about things like acknowledgement, the table of content and everything. So as you can see in this preface.tex file, you have chapter. You put start there so that the chapter will not be named, will not be numbered, right? For the other chapter you saw, for chapter 1, for instance, you see we don't have to put that star because we want this chapter to be numbered, right? So for the preface chapter now, so you have chapter preface, add content line, table of content, chapter preface. So this book grew from lecture notes, right? And then if you want to add like a acknowledgement, so you can now say, I thank, blah, blah, blah. Maybe things like forward, dedication, and all that comes in the beginning of the book. That's what preface is about. And then for bibliography, we've seen this before. You need a references.bib file. All right. So you put all the references, the author, the title, the year, the publisher, the address. That's for book. For title, you need author, title, journal, year, volume, number, and pages like that. Then for indices now, so you have index and glossary acronyms. So this one you are going to find in chapters. So you have to define term like metric space, contraction mapping. Then you can have new acronym ML, machine learning. So each use of GLS, ML appears throughout the book. So once you have this GLS or term thing, so they are going to appear. So this is for index, this is for glossaries. Okay. So glossary entries put in preamble or a separate file. You can use /inputs, all right? Then /new glossary, and all of this name is metrics, a description. So maybe you want to describe a particular idea. So it's set with a distance function satisfying positivity, symmetry, triangle, inequality. So this now build steps with build steps. Here we talked about index and everything. So build step must include make index handled automatically by Latexmk with I make index and make glossaries also auto when configured. Otherwise, run it manually once. So you're going to see how all of these things play together. So let's talk about page layout and options. So for print now, so for print, you can have two-side, larger inner margins. Consider use package fancy header for if you need to use headers and footers. So for better class defaults, you can consider document class SCR book. So if you want better class defaults, then that's ComaScript or Memoir for a single powerful class. Then for line spacing, you can have 1/2 spacing for drafts, right? Of course, there's also double spacing. Okay, then talking for reliable build now, you now need something like LaTeX MKRC, which is optional but recommended. So inside of that, you can have PDF mode equals 1. You're going to see what a LaTeX MKRC means because I have a folder that contains the actual thing that will make us create a book. Okay, so here 1 equals PDF LaTeX, for instance. So PDF mode is 1. So 1 is PDF LaTeX. So you can use 4 for Lua LaTeX and 5 for XE LaTeX. I mean, I use PDF LaTeX for the most part. So PDF mode is 1. Then BibTeX underscore use is 2. So use bybar when BibLaTeX is detected. Then out underscore dr build, aux underscore dr build. So that's optional, for reliable build. But I mean, my file contains all that. And you have CLI, that's PDF LaTeX plus bybar. So this is what that contains: PDF LaTeX main, bybar main, PDF LaTeX main, PDF LaTeX main, like that. Then you have with Latexmk, which is automatic, you have Latexmk minus PDF, dash PDF main.tex. Then you have cross-references and best practices. So if you want to deal with cross-references, you can always label, / label, then maybe chapter something, which you have. So which you put, if you want to reference a chapter, you already have a label under that chapter, or a section, or a figure, or a theorem right under the numbered entity. Let me say, I think this should be always use all that, right? Okay, always use all this right under the numbered entity, be it a chapter. Then you can use cref and small cref and big cref for context-aware references, right? Then some common pitfalls and quick fixes for them will be all this. So you can have undefined control sequence, like you can have missing package or wrong engine, like XE or Lua versus PDF. So be sure if you're using PDF LaTeX, be sure that's what you don't have anything that works with XE and Lua LaTeX that won't work in PDF LaTeX. So you want to pay attention to all that. If citations don't appear, you may have to run by check.bib path and add bib resource. Okay. Then references show question marks. So it means you have to recompile. In that case, LaTeX needs multiple passes to actually get the references compiled properly. Then figure not found. So you can confirm relative path, extension, and graphics path if used. So you want to be sure the right figures are in the proper places. So then authoring workflow tips. So you need to write chapters as separate files, keep each section focused, use comments like %to to track edits, keep figures as vector PDF for diagrams when possible. So vector PDF is, make sure the diagram or figure is in a has a high resolution. I think that's the idea. Then define macros once in the preamble and avoid redefining in chapters. So quick checklist, once you're done with all that, right? You have quick checklist. First of all, you want to check the title page, the table of content, preface and acknowledgements, greater than or equal to 3 chapters with sections and subsections. So, I mean, I've been writing a lot of books since January 2024, right? And most of the books have 10 chapters, by standard. There's no rule that says your book must only be 10 chapters. No, not at all, right? But if you have 10 chapters, make sure all the 10 appear. Then you have at least one figure plus one table, then theorem, definition, and environments, all that. Then cross-references via cleverref, then citations via BibLaTeX and Bible, index terms plus glossary / acronyms, clean build with Latexmk. You're going to see all that. So we have a mini project finally. So we're going to do like a first 3-chapter book, right? So the deliverables are this, scope and theme. Choose a theme, e.g. introduction to optimization or design patterns in Python, as you like it. Then you have the structure of the 3-page book, a 3-chapter book rather. So you have preface, like 1 or 2 pages. Chapter 1 is foundations, include a definition plus theorem with proof sketch. Chapter 2, you have applications, include 1 figure and 1 table with captions plus labels. Chapter 3 is case study, include a short example with equations. Then scholarly apparatus, you need at least 5 sources in reference.bib. That's 1 book plus 2 journal article plus 2 web or tech reports. That's just just to guide. Then, of course, if you're writing a proper book, you know what you need. Then use 3 cross references, e.g., cref across chapters. Add 10 index terms via /term and 5 glossary entries with 2 acronyms. Then, for typography and layout, you can use one side for draft, then try 2 sides and adjust margins. Then enable microtype, use book tabs for tables. Then build and submission, compile with Latexmk minus PDF min.tech. Now, this will not be necessary if you do it on Overleaf and Text Studio, for instance. Then you can submit. So what you submit, you have main.pdf plus project folder. That's the source now, which contains all the .tech, all the main PDF and everything. Then bonus, you can switch engine to LaTeX and use a system font. So LaTeX seems to work with some special fonts. So you have use package font tech plus set main fonts, text, Jira, Pagella, remove inputs, ink, and font ink when using LaTeX and Lua LaTeX, right? So, having said all of this, let's go ahead and see a proper situation. Okay, so I'm going to open, this is my folder, and talking about LaTeX book project, like open this. All these things I've talked about, you see, we have, first of all, we have the main document, which is a text file. Okay, so that's the main document. So in that main document, you're going to see everything we saw over there. I think let me do Overleaf because it's difficult to expand here. So let me go to Overleaf so you can see everything more clearly. So I come here now, and then I can even start a new project. Okay, I start a new project, as go for a blank project, for instance. So I just say LaTeX book project. Okay, LaTeX book project. I mean, you could have done that in Text Studio. So, but for easier expansion. So what I'm then going to do is I'm going to upload the content of that file. So I'm just going to upload. I go to select files, then I take it to the desktop, talking about Math with EJD, and then I talk about LaTeX typesetting. This is the book folder, LaTeX book project. So I'm going to upload all these folders, all these things inside that place. So I'll just open, then I just say overwrite. Okay, so I mean, I've done that. So if you look at the main now, look at the main. This is the main, so I can just compile that. So it's taking a bit of time, but before that happens, so look at this now. You have the main document, which is a text file. You have the make file. Now, this make file, we can easily open it in Notepad, and you see it contains just very simple stuff like what you're going to see in a moment. Yeah, see what it contains. Make file optional all. LaTeX make minus PDF main.tex clean. LaTeX mk minus c rm minus rf build. So for that's for easy build, right? And then you have this is main, this is preface, right? So in the preface, we can even try to open. Okay, if I open the main, this is the main right here. So in the main, you have all the documents class and its book. Then you have LaTeX MKRC, then you have the chapters. So you see CHO1, CHO2, CHO3 for the chapters. And then you have Bib, where you have the references, which you can still open and see what it contains. So you already know how that goes because we talked about references on its own. Okay, this is not opening. Why? Okay, it has opened already. So it's right here. So you see all the references, book, online, all those things. And then what else do we have? We have LaTeX MKRC. We can open using Notepad, like make file. So LaTeX MKRC, we saw all this $PDF mode one, that's for PDF LaTeX and all that. We saw this previously when I was explaining. Okay, so now we are here now. Okay, now I think there's a bit of trouble here. This is not responding. Okay, I think that's the overleaf trouble, which is okay. So it means we have to use this like that. We have to use um Text Studio. Okay, there should be a way to zoom it out or so. Let me see. We've not done that in a while. Okay, well, so if I run this now, this is the main, it's all the set space and everything. So you've seen all the components in that folder. So you have to be sure everything is in that folder. So this is running. So coming back here now, okay, you can see some things have been produced here already. Do we have the figures? Okay, I don't have a folder for figures here. So it means okay, if you have figures, so you need to put figures and figures in that file. So you need a folder like this for figures separately. So this is going, and then let's see what this has given us. So it's still, when you compare for the first time, it may take a bit of time. And because the book has many parts, so it's reading all the different parts you have put together. So that's all ongoing. So you can see that working right here. It's sad. Yeah, finally it's here. So everything has worked well now. So so you see that in this main place, you don't have all those you don't have elaborate apart from the formatting. So this main file is just to put things together, basically, right? So document class book, so input enc for if you're using PDF LaTeX, if you're using Lua LaTeX and Excel LaTeX, you have to remove. Then use package, font enc. I mean, all those things we saw the other time. And then what else? For the cross references, bibliography, you have all of these things. So you have bib/references.bib, then index and glossary, I make in IDX and all that. What else? So new acronym we say LP is for linear programming. So we can always, so this one helps you that instead of writing linear programming every time, you just have LP alone. Maybe I should even use this idea to write a book on linear programming because I have videos on linear programming. Let's see if it is something I can pull off. Okay. Then you have Karush Kontoka. So anyway, you see KKT, you know that's Karush Kontoka. So that's talking about acronyms. For glossaries now, so you have name convex set, description, the set where the line segment between any 2 points lies entirely in the set. Okay. The line segment between any 2 points lies entirely in the set. Then you have objective function. So these are glossaries. So these are things that will be defined in the book. Then you have things like duality gap, subgradient, all described there under the glossary. Then so you have new command. So anyway, you see /r, that's math BBR. We are going to see that in the book. Then the title of this book is Introductory Optimization, a concise book project. So also Emmanuel, Jason, and so on, all that. Then now you see, instead of writing out, okay, you begin the document, you have front matter, make title, table of contents, and then you include, so those other tech files, then you just include them in the main. So you just include preface, main matter, include chapters /ch01, include chapters 02, blah blah. Then back matter, you have the print glossary for talking about list of acronyms and all that. Print glossary, title list glossary, then print index, print bibliography, and all of that put together is what has led to this book now. So I can expand this and maybe okay. I mean that's okay. I think it's better I just exit it as a proper PDF. So I just save this and go for it in the downloads. Okay, so this is the proper book now. Okay, so you see, so this is the title page, Introductory Optimization, a concise book project managed so November 11, 2025. So these are the contents. So because I have 3 chapters now, for first chapter, we have foundations of optimization, sets, convexity, and continuity. Okay, well, I think I should have shown you that, right? I should have shown you all this. All you just need to do is come here again. So this same place. I think that's really important. Where did you get all those things from in chapters? So it's still here. So if you come to chapters, for instance, and you open chapter 01, so you see in the tech format, we have chapter is foundations of optimization, and then we consider problems of the form, and that's where you do all the whole typing, and that's chapter 1. Then for chapter 2, of course, don't forget that apart from the chapters, you have, chapters are in sections, you have definitions, you have all of these things. So that's in chapter 1. So instead of writing everything together in one place, you can write them in separate chapters and then just assemble everything. So that way you can manage things. That makes for modularity, right? You can do things in parts and then put all of them together at the end of the day. So chapter 2 is applications and geometry. So, and then you can label that in case you want to refer to. This chapter builds geometric intuition and connects to practice. We revisit where Strauss by showing a compact stable set, blah, blah, blah. So you have, Tick's picture to demonstrate some ideas. Then another section, method comparison, like you have some toy data to show method iterations, final objective, and notes. And then you have some cross references right there, which you're going to see as you look at the PDF. Then the third chapter, this is it right now. So you open it again. So if you want to add another chapter, you just create another tag and give it a chapter title, which is the first thing you do. This is chapter 3, a short case study, ridge regression. We consider term because we want ridge regression to appear in the index. That's why we add term to it as a simple convex case study that illustrates modeling and algorithm. So you have section, you have a model, give data, blah blah blah. Given data, this. Begin equation, end equation, and we keep on. Another section, first order method, another section, dual viewpoint, and GLS, KKT. So this glossary now, so anywhere you see KKT, you already know that's Karush Kontoka. The section, you have pointers and practice, and so on and so forth. So at the end of the day, when you come to main, you have everything output here. So now back to this. So you see all these chapters in the main, you just assemble them by using / include chapter /ch01. So you have sets, convexity, and continuity, first order optimality, index terms and notation. For chapter 2, you have applications and geometry. It's a simple geometric picture method. Now you see all this red line tells you that if you want to go to any part of this now, for instance, if I want to go to pointers and practice, I just click on it. It takes me there directly, pointers and practice. Just takes me there straight up. Okay. But let's go back to the beginning. Okay, so now this is the beginning again. So, so we go for the preface now. So this concise book grew from course notes and short workshops on mathematical optimization. It focuses on core ideas like objective function, feasible region, duality, and first-order methods. The tone is practical but rigorous. How to use the book. Start with chapter 1 to establish conceptual and notational clarity. Then browse chapter 2 for geometric intuition, using figures and small empirical table. Finally, chapter 3 presents a short case study, linking modeling and algorithms. Then we assume basic real analysis and linear algebra. For further reading, see. So I think there's something wrong with this citation. It's not coming out the proper way. So let's go and see if there's something I can correct. So I go into the main folder again and look for the book project, and I go for preface. So this is the preface. There's something I can do to make things better here, especially where citation is concerned. So why is text cite not giving us the proper thing? That's one question. Can I just use only cites and have it work? Let's hope that works. So let me just use only cite and run it again, because the citation should come out in a particular way, but this is not doing that. So if I use, instead of text cite, if I use cite, let's see if that works properly. Okay, now it's done. So the site is still the same way. So that's something we need to troubleshoot. What if I use site P? Oh, that doesn't work. How about site C? It doesn't work. So I have to do something about that. But for now, let's just use it the way it is. But that's something that should be taken care of for sure. So in chapter 1, and we have foundations of optimization. We consider problems of the form, blah, 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 blah. Set, convexity, and continuity. You have all those definitions. First order optimality, you have all these. Then index terms and notation. So for chapter 2, you have applications and geometry. This chapter builds geometric intuition and connects to practice. We revisit theorem 1.1 by showing a compact feasible set, blah, blah, blah. So you have a simple geometric picture. Then you have method comparison using a particular toy data. So for you have cross references now. The geometric picture in figure 2.1 ties back to definition 1.1 and existence theorem 1.1. We visit this again in chapter 3. Okay, so we go on to chapter 3. Okay, I mean, chapter 2 still has the table. So we have toy comparison of 3 methods on a smooth convex objective. Lower is better, right? So for gradient descent method for fixed step, you have 120 iterations. Final objective is 1.23 minus 4. So that's bigger than the rest, right? It is sensitive to step size. Then gradient descent for backtracking, 65 iterations, 8.10 e raised to minus 4. This is robust to scaling. And nested over selected GD, just 40 iterations, and we get 5.95 times 10 raised to minus 4, which is smaller than this one. So this is like the best convergence rate given these 3 methods. So this is just the third comparison of 3 methods on a smooth convex objective. And of course, lower is better, right? Because this is a minimization problem, for instance. Let me see. Okay. Yeah, it's a minimization problem. So in chapter 3 now, we have a short case study for ridge regression. So we consider ridge regression as a simple convex case study that illustrates modeling and algorithms. So you have this model given data, this whole math thing. So you have this whole thing, this is strictly convex objective with closed form solution, blah, blah. Convexity ensures uniqueness. Existence follows from theorem 1.1. Then we have first order method. So gradient descent with backtracking line search. You have this right here, so 3 chapters, but everything ends up in it's like 5 pages. Where's the last page? Okay, we still have some stuff like this. So this is okay, let me just make it page by page. So chapter 3 now, we have the first order method, and we have dual viewpoint and Karush-Kontoka, right? Define Lagrangian and write KKT optimality conditions. Then we have pointers and practice. You have all of this right here. Okay. Then you have so this is where the index thing came now. So all these words you are seeing here, they actually came because you used, each time they came up, you used term, case study, Hessian, constraint Lagrangian. So in this case, now, if you want to learn more about ridge regression, you just click you can just go to chapter 5 and you find it there. This is, I mean, page 5. I mean, page 5, not chapter 5. So you go to, this is page 5 now, I think. Yeah, I think it's easier this way. So this is page 5. So you're going to find ridge regression right here. Okay. So what else are we looking for? If you're looking for, say, the concept of duality gap, that's page 6. So you just go to page 6 and you have duality gap somewhere. So the duality gap here is 0 because the problem is convex. Okay. So you have index, and did we see glossary? I think there should be glossary too, because okay, we don't have glossary here, really. Okay, all this linear programming, KKT conditions. So if I click on this now, it takes me to, okay, the glossary isn't showing here. Okay, that may be due to some kind of error. But the beautiful thing is that if you want to work on a book, you can easily get a template online. So just say you're looking for a book template. All you just need to do is, but sometimes working with some book templates, like there was a time I was looking for a book template fit for Amazon. In fact, maybe I'll just patiently try and do a book template that is Amazon ready. So I just type my stuff there and get ready to be ready to publish it on Amazon straight up. Okay. Yeah, so with this, let's say we have come to the end of this particular video on writing books with LaTeX. So once you get this right, you don't have to stress a lot about, doing your indexing, doing your references, glossaries, and things like that. So this is really helpful. So of course, you need a bit of, if you already use LaTeX, you just need to be able to figure it out, how best this can go for you. Interestingly, you can use AI to generate a template that you can use for yourself. So you just need to specify what kind of book you want to write, how you want it to be, the kind of referencing and everything. So if you are patient, you can generate a folder, a template that you can use to write your book. All right. So thank you so much for listening. Let me know how helpful this is for you. And if there's something else you'd like me to try, feel very free to let me know. If you have subscribed already, I thank you so much for that. If you have not subscribed, of course, why not go ahead and subscribe right away? Hit the notification bell so you can always get alerted each time a new video is released. Then you can take it a step further. Become a member of the channel by clicking on join. You have 3 levels of membership with special privileges. Ultimately, don't forget to comment, like, and share so that more people can have access to the great content I have going on it. So I come your way again. Keep doing LaTeX right. By the way, the next video I'll be talking about how you can use LaTeX for is it for chemical equations now? I think it's for chemical equations. No, non-mathematical symbols. And then the video after that will be about chemical equations. So if you're into chemistry and want to see how to use LaTeX for chemistry, watch out for that. See you. Bye.